5. So carrying on with exponent laws, we just have more, right? So we're gonna just add some more exponent laws to this. So the next ones. So now let's do it this way, right? If we had 2 to the power of 3 to the power of 2. So we're going like a power to a power now. This is a very powerful law.
I figured it out. Oh my God.
Add them together instead.
Well,
multiply.
Yeah. You just turned up. All right, so really, yeah, some of you guys kind of figured out what we're going to do here, especially because the answer's there. But let's write out what's actually happening here, right? 2 to the power of 3 is really 2 times 2 times 2, right? And then remember what it means to write to the power of something, right? It means 2 times 2 times 2. And then writing that again, right? It's this squared. So we need to, like, if it's all of that squared, then I need to write it all again. 2 times 2 times 2. So what would that be? That would be 2 to the power of, how many 2's are there? 6. So in the end, it was 2 to the power of 3 to the power of 2. What did we do there to get, we multiplied, right? So if you go a power to a power, then we're going to be multiplying now. So that's our next exponent law. Okay, so you guys have 3 so far. So here it is written out formally. A to the power of x times y is just equal to a to the power of x. Sorry, did I say times? A to the power of x to the power of y is the same as a to the power of x times y. Yeah. Okay, so let's do these. So number 1, again, I'll let you guys do this. So I'll pause it and see what you get. So the first one here. So what do we do with exponents when you're going a power to a power? We multiply, right? So this will be 4 to the power of 15. You guys would be very surprised, or maybe you wouldn't, how often people would go 5 plus 3 to get 8, right? So just be careful. That, like, if you're going to make a mistake, that's probably it. I still do it every once in a while too, because you just kind of get complacent and add those. So just be careful, right? It's just paying attention. So 4 to the power of 15. All right. So now in this one, this would be, this one actually is a little bit more complicated than we think.
Would it be negative because the powers are inside the bracket?
Yeah, so here, let's think about this one a little more closely. Before I even get going here, I've got a negative number, and it's being raised to the power of 2. Is this thing coming out negative, or is it coming out positive?
Positive, because the exponent is positive.
It's gonna be positive here, isn't it? Yeah, because this is gonna come out positive, because this isn't a negative number, but if it's raised to an even exponent, the thing's going to come out positive, right? So that's kind of a tricky little guy there for sure. So either way, if I get rid of that one, it's still going to be 2 to the power of 6 times 2, so 12. All right, next one. This will be 14 to the power of 2. 2 times 0 is 0. You were thinking 1, yeah. 2 to the power of 0 is 0, right? So that's 14 to the power of 0. Now, I wouldn't typically leave it that way, though. Yeah, what is 14 to the power of 0? What's anything to the power of 0? 1. This is really the same thing as 1. And again, just thinking of the same thing in different terms here, we also could have just known that without doing that exponent law, because this is to the power of 0. And what's anything to the power of 0? 1. This was 1 just from the beginning, right? Always has.
Yo, he knows the meme. He knows it.
This one here. So we've just really got 2 pieces going on here now, right? There's like an order of operations thing happening. What do we do first with order of operations? Do we do exponents or multiplying? We do exponents, right? So I'm gonna do this one and this one, probably in the same step, and then I'm gonna multiply them, right? Like those come first and then we multiply. So let's do the first one here. 3 to the power of 3 to the power of 2 would be the same as 3 to the power of 6, right? 3 times 2 is 6. Times 3 to the power of 4 times 1 is 4. Now what? Now, yep.
You plus the 6 and the 4, which gives you 3 to the power.
Right. We're going to add this now. And remember, we work our way down in math, right? So I'm going to write this just right underneath. 3 to the power of 6 plus 4 is 10. We're adding those because we were multiplying with the same base. Okay. Now another, this is kind of a law. This one's not too bad though. All right. So the next little one to consider here, if we had 2 times 3 to the power of 3, well, we could really rewrite that as 2 times 3 3 times, right? Like 1, 2, 3 times. Okay? Now, if we did that, you can see, well, we have 1, 2, 3 2s, and we have 1, 2, 3 3s, right? So really what we did here is we went 2 to the power of 3, right? 3 times, and 3 to the power of 3. I know that seemed a little bit complicated, but in the end, all we really meant here was that if we have 2 times 3 in brackets and then to the power of 3, we just have to go 2 to the power of 3 times 3 to the power of 3. You just have to make raise both of those things to the power of 3. Yeah. Yeah, the question was, couldn't we just simplify this thing in the middle down to 2 times 3 is 6 to the power of 3? Yeah, we could have done that too. You get the same answer in the end. The reason why I'm just kind of showing you that we could have went 2 to the power of 3 and 3 to the power of 3 is especially when we get into like later years, this would have been something more like a times b to the power of 3. And then I can't actually just multiply those because I don't know what they are. But I could rewrite this as a to the power of 3 times b to the power of 3. You can like, yeah, apply the power to both of those. Make sense? Yeah, okay. Actually, I shouldn't say in later years. We have to do that as well. You guys have some questions where I'll throw some variables in there where you'll have to do the same.
No.
Fun.
Okay, so yeah, in general, here's our next rule. A times b to the power of y is the same thing as a to the y times b to the y. Okay, let's practice. Can you guys do these ones for me? Okay, so the next one here, well, this negative out front is just kind of hanging out there, right? I'm going to leave it alone. I'm just going to leave it hanging out front there, and then apply this 3 to both of those. So this will still just be negative, and then 2 to the power of 3 times 1 to the power of 3.
Yeah. I did it as negative 2.
Yeah.
Because that wouldn't that change the answer?
Yeah, that would.
Because it would take off both.
A negative.
Yeah, you're right. Like technically, we haven't done much of this, but when we get into like the algebra here, that would also be the same thing as negative 2 to the power of 3, and then times negative 1 to the power of 3. Like that negative gets distributed into both of them.
Oh, so I did it.
Is that how you wrote it?
Yeah, so it does do that. You have negative with both, so it's negative 2
Times negative 1.
times negative 1.
Yeah. Yeah, that's technically, we just haven't done much of that. That's going to come like in the next units there where we multiply those in. Yep. Yeah, and for the most part, guys, this rule is kind of funny because typically we would just multiply those ones in the middle and then go from there. I just want you guys to see that the exponent applies to both. Yeah. Okay. Next one here, this would be negative 6 to the power of 2. And this one's a little funny though too because it's actually negative 6 itself. You can think about that as like negative 6 to the power of 2. Right? It's actually like as this whole thing is being applied to the power of 2. So that thing's going to come out positive, won't it? In the end. Times 4 to the power of 2.
What happened if you don't write the bracket?
Well, you would have to in this one because that'd be a different answer. If you would have wrote out negative 6 squared times 4 squared,
Yeah.
that'd give you a different answer. Because that one doesn't have the brackets around it like that. Right? That would come out negative, right? That'd be negative 36.
Okay.
This one would be positive 36. Yeah? Okay. I know those can be tricky. Okay.
I guess you would ignore it till your answer.
Yeah. Okay, and then the last one here, 18 to the power of 6 over 6 to the power of 6. So dividing just has the same rule. You just apply it to both. I'm going to give you guys one hard one, then I'm going to let you get to work. So
Will this really be hard?
yeah, it's really tough. Okay, can you guys write this one down with me?
Okay.
Squared b
probably gonna be really easy, but he's making
So
it
probably
much
just keep
harder.
5.
He's gonna put his.
Oh.
Okay.
So
In the end here, guys, this is going to be a to the power of something times b to the power of something.
I think it's.
So you guys need to figure out what those two numbers are.